Hi everyone, my name is Ralph. I'm the Director of Product Development at Mantel, where we're developing the material solution to carbon capture. At Mantel, we're putting together the team to solve some of the toughest challenges in point source carbon capture. Here you can see our team with some of the equipment in the lab. Many of the team are MIT grads like myself. We're supported by the Breakthrough Energy Fellows program, and we are backed by the Engine and New Climate Ventures. So I think most of you are probably familiar with the problem we're solving. We are going to need to capture billions of tons of CO2 every year to meet net zero goals by 2050. And carbon capture is a particularly attractive technology for certain sectors of industry that are hard to abate any other way. Think petrochemicals, chemical manufacturing, pulp and paper, really any industry that has heavy emitting boilers on site. Carbon capture can also unlock negative emissions if you burn biofuels and capture the carbon. Now, carbon capture has been demonstrated at scale before. This is Petronova, a carbon capture plant in Texas that captured 5,000 tons of CO2 a day, a huge quantity. But we've also heard from our industry partners that this is the plant that killed carbon capture because it was simply too expensive. And Mantel's mission is to reduce the cost of point source carbon capture. So how do we reduce costs? By inventing and implementing an entirely new type of material for carbon capture. These are molten borates, which operate at high temperature and in the liquid phase, as opposed to the competing technologies such as the amines that drive the Petronova plant that operate at lower temperatures or in solid phase. Now, what's the advantage of using a high temperature liquid phase material for carbon capture? To explain that, I'm an engineer, I'm sorry, I have to give you a flow diagram. This is how you do carbon capture these days. You take your emitting asset, you bolt on a carbon capture system that absorbs and desorbs CO2 out the back of the unit. You do this all at low temperature. Now, carbon capture requires a huge amount of input energy, that's the red arrow, and you also then waste or reject that heat at low temperature, cannot be reused. As a result, the energy cost is massive. Mantel's technology, on the other hand, with that high temperature liquid sorbent, allows us to reconfigure how the configuration of the system. And we do the absorption and desorption of CO2 at high temperature. The advantage of this is that all the energy we put in to desorb CO2 can be recovered as useful energy, high temperature steam. As a result, we massively cut the energy requirement for the carbon capture. So that's the mission of Mantel, to cut the levelized cost of point source carbon capture by at least 50% relative to the state of the art. So what's the state of the technology? Well, it was invented in a lab in MIT about 5 years ago, and now we are testing it in our lab at our offices. We have equipment we call the test flow loop, which is designed to capture about half a ton of CO2 a day. This is actually a huge amount for a laboratory environment. We are in the process of designing our demonstration plant, which will capture 5 tons of CO2 per day at a partner site. And from there, we'll scale and sell commercial units that go up to the size of the Petronova plant I mentioned earlier. So Mantel is the provider of the technology. We provide the technology to capture the CO2 from these plants, such as the ones you see on this screen. And we foresee working with the owners and operators of these plants to design our systems integration with your emitting facilities. So that's why I'm here today. I'm here to find people, industrial partners who are seeking a way to decarbonize their existing emitting units, boilers, kilns, heaters, really any process heater that burns fossil fuel. We're targeting hard to abate sectors, think chemical manufacturing, petrochemicals, really heavy industry is where we work. And the next step for an engagement with us is for us to design an integration of our technology into your system. I do this pretty frequently now, designing conceptual designs of our systems integration with different types of industries. So if this sounds like you, please reach out. We'd love to talk. I'll be next door. Thank you very much.